Welcome to qnawire.
In order not to fall over, the net torque on the cyclist about an axis through the center of mass and parallel to the ground must be zero. Consider the free body diagram I have drawn here. So the sum of forces, the sum of the torques about the center of mass with counterclockwise as positive, and we can set this torque should to be equal to zero. Oh, so this is equal to zero, and about uh, the axis through center of mass and parallel to the ground, we have the forces contributing to the torque that are just Fn and Fy. Sorry, Fn and F friction. So if we take the counterclockwise to be positive, so Fn times x is the positive torque uh, because it's anticlockwise, and we have another torque due to F friction, which is F friction times the perpendicular distance, which is y, and this torque is clockwise, so it should be negative, and the sum is 0. So we have Fn x minus F friction y equal to 0. This gives x over y to be equal to F friction over Fn. And if this is theta, then tan theta will be equal to x over y. So this is what we got for tan theta. Now for part B, the cyclist is not accelerating vertically, so the net acceleration in the vertical direction is 0. So if we write Newton's law for the vertical direction, the net acceleration is 0, so the right hand side is 0. Now if we take positive y-axis to be upward and positive x-axis to be towards the right, then we have Fn minus mg to be equal to 0. This gives Fn to be equal to mg. Now the cyclist is accelerating horizontally because he is traveling in a circle. So this is the cyclist and this is the center of mass. This is the tire of the cyclist, and this is the center of mass of the cycle, including the cyclist. Now, since he's traveling in a circle, there is some net acceleration in the horizontal direction. So ax is not equal to 0 in this case. And the frictional force must be supplying the centripetal force here, because that's the only force that's available here. So this should be the force that's supplying the centripetal force for which the cyclist is traveling in a circle. So F friction must be equal to mv square over r. Now we can use these two expressions and plug them into this equation to find the expression for okay to find the expression for tan theta. So we get tan theta to be equal to mv square over r over mg, and this is in fact equal to mv square over r. This means that over rg, therefore theta will be equal to tan inverse of v square over g. So let me just write it in the next page. So we got tan theta to be equal to v square over rg. So theta will be equal to tan inverse of v square over rg. Now we have v to be equal to 9.2 meter per second, r is 12 meter, and g is acceleration due to gravity, which is 9.8 meter per second square. And this gives theta to be equal to 35.74 seconds. Now coming to the last part. So we have friction supplying the centripetal force. So this should be equal to mv square over r. Now since F friction is inversely proportional to r, considering velocity and mass are constants, therefore the smallest turning radius should result in the maximum force. And also the maximum static frictional force is mu Fn, where mu is the static coefficient of friction. So maximum force is mu s times Fn. Now we can use this value over here to calculate the radius. So we have mu s times Fn to be equal to mv square over r. Now since Fn is mass times g as we got here, we can use that over here. So we have mu s times mg to be equal to mv square over r. So the masses cancel out and we get r to be equal to v square over mu sg. Now we can solve this given mu s is 0.65 and we will get that radius comes out to be 13 meter.